We recently had a request for determining a DQ0 offset. So I made a perception workbench called DQ0 Finder. I loaded in some data, and I'm just going to walk through the equations first. So we want to look at our back EMF. So I loaded up phase one voltage. I need to determine the time period for which basically I'm figuring out the speed of the machine. So I need the frequency, which is pulled from our fundamental frequency. I want our mechanical angle, and then I'm going to demonstrate the DQ0. So I pull in I1, I2, I3, number of pole pairs, which in this case is 3. In this circumstance, I'm actually filtering my voltage. I didn't have a back EMF voltage, so I had something that was inverter driven, so I filtered it out. In the post process with perception, we can use phaseless filtering. So I shouldn't have a phase shift. It should work pretty well. For example, I think it'll work great. For more precise results, I do advise having the pure back EMF, whether you spin a shaft with the hand or you run it with your dyno. So we're going to do a cycle, which we're just determining the frequency and the time we're determining the period of the back EMF. So 1 over the frequency, and I had this X position. For those of you who know perception, we have cursors. So I'm pulling the X position from one of the cursors. I take the time. So in the demonstration I'm going to show in a minute, we're going to look at position of cursor 1 versus cursor 2, take the absolute value of that. Time percentage, we're going to look at the total time period of the fundamental frequency, and then we're going to take the percentage of the offset between the encoder angle and the back EMF. Again, we'll show that. Then it's just 360 times that time to get to degrees, and then a simple conversion to get to radians. And then I run the DQ0 calculation. Perception's got a really easy way to run DQ0 in the post process or in the real time. So what was I just babbling about? So here I have my back EMF in blue, and I have my encoder in black, and it's that sawtooth wave. And let me mess up my cursors here. Cursor 1, cursor 2, these are important. These are where our equations are coming from. So if I select my VFilt, and I select one of my cursors, and I say, all right, we go to next 0, I've identified the 0 position of my fundamental frequency. So we want that rising edge back EMF 0. I then go to my second cursor, and now I want to find my angle. So I click on YMEC, I grab my cursor, and I say, okay, I want to go to the next maximum. Now I've aligned with my mechanical 0. So cursor 1 is mechanical 0, cursor 2 is magnetic 0, and that math I showed in the formulas just calculates this offset angle of 278 degrees, or 4.85 rads. If we go to my DQ0, we're going to see ID that's basically DC. We're going to see an IQ that's negative DC, but this negative value is good because my torque is negative. So we got negative IQ lining up with negative torque, and this looks good. Now, where can you go wrong? I think this might be more fun. Let's say you want to look at this 0 over here, and oh, I was not selected on my back EMF. So cursor 2, back EMF, next 0. I now align to the rising edge 0, but the one after the reset. I think this is just by nature of something I've coded up, but this gives our offset as 81 degrees. It should probably be negative 81. And now I have a positive IQ with my negative torque. So this would be wrong. So this is why we want to go to that rising edge, that negative going positive current, back EMF before the angle offset. It's because I have that absolute value in there. So I probably could code this up a little smarter. But that is an area where people go awry or go wrong, and then they get that negative IQ value. So there are things you can do to change that. And this is a pretty safe way, always going to that rising edge before the angle for the calculation. That should give you the correct calculation. Another area where people can go wrong is having the wrong pole pairs. Let's say I have 2 pole pairs. Now I have a sine wave for my ID and IQ. That's no good. This is because the reference frame isn't correct. So again, make sure your sine is correct on your angles, make sure your pole pairs are correct, and you will be getting a nice DQ0. And we can even do fun things like, XY display, where maybe we see, IQ versus ID in a nice little, static offset here. So it's cool stuff. All right. I hope this is helpful, and please reach out if there's any questions.